Okay, so this is the last video on the new practice sheet, and this is a tow truck pulling a car. Okay, so I'm going to call it car and T for truck, and pulling it, whatever. We have the earth. Okay, so who is interacting? We've got the truck and the ground, the car and the ground. Okay, both of them in the earth, and they are touching each other. All right. Okay, so let's make a force diagram. Again, we're going to put the car on the left and the truck on the right, so it matches the picture. Okay, and let's look at the car. Okay, he's having at least 3 interactions and possibly friction. Okay, so let's look first at his weight, which is the force of gravity on the car from the earth. All right, and in the problem statement, it showed that the mass of the car was 600 kilograms. Okay, so when I look at that, I know the mass is 600 kilograms, so I have to multiply by 10 newtons per kilogram to find out that the weight is 6,000 newtons. Okay, so this is going to be 6,000. All right. The car is also interacting with the ground. The ground is pushing up on the car because up and down has to be balanced. It's not moving up and down, so that has to be 6,000 newtons also. Okay. All right, and then there's an interaction between the car and the truck. So, are the car and the truck pushing each other, or are they pulling each other? All right, so they're connected by some kind of a rope or tow hook or something, right? So that's a pull. All right, so the car is the feeler. He's feeling a pull to the right. So that's a tension force on the car from the truck because he's being pulled to the right with, I believe it was 5,000 newtons. Let me just double check. 5,000, oh no, friction. Well, it's going to be. Let's pretend like we don't know that yet, okay? Because we're going to do this backwards. Okay, so we don't know, let's say we don't know it yet, okay? Right, it's being pulled. Okay, so the car is moving at a constant speed, so then we also know there must be a force of friction, okay, on the car from the ground that's going the opposite direction. And these two are going to have to be the same because the speed is constant, so the forces have to be balanced. All right, so let's look at the truck. Okay, the truck has a weight, as does everything. So on the truck from the earth, and that is given as 10,000 newtons. It's already in newtons, so no need to change it, no need to do anything. It's already all set. Okay, the ground has to be pushing up on the truck. That also has to be 10,000 newtons because the forces are balanced. He's not moving up and down. Okay, so if we look at the truck, we see he's interacting with the ground and the earth. He's also interacting with the car. Okay, it's not what he's doing, it's being done to him. All right, he is pulling the car to the right, but that's not what we're asking because he's the feeler. So what is the car doing to him? Okay, the car has to be pulling back on him. Okay, here's your pair. Right, equal and opposite, feeler and dealer have swapped. So if the car pulls the truck pulls the car. That's the pair force. Okay, and if they're moving at a constant speed, there has to be a force this way propelling them forward. The only thing left to be would be the friction. Okay, that's the wheels catching on the ground and propelling this truck forward. Okay, and again, we're just looking at right at the surface, okay? Right, you're just looking right at the surface. All right, and there has to be, something has to be pushing him forward. It has to be that. Again, think about if he was on ice, this wouldn't happen. We couldn't get this force because there'd be nothing to grab to push him forward. Okay, now this one's a little bit different because it says the 5,000 newtons of friction on the wheels of the tow truck propel it forward. Okay, so this is trying to tell you this. There's 5,000 newtons, okay, of friction, which is propelling the truck forward. This is the rubbing between the tires and the ground. Okay, that's what's getting him to go forward. All right, If they're moving at a constant speed, if this is 5,000, then this is 5,000 because they have to be balanced because he's moving at a constant speed. All right, now we look for our pair. Once I have one side of the pair, I know that this guy also has to be 5,000. Okay, and then if this is 5,000, I know this guy has to be 5,000 because the forces are balanced because he's moving at a constant speed. All right, so this is the part right here. All of these soon are not going to be all equal because things are going to start accelerating. That's why you need to get this stuff handled, because in very shortly, like 2 days, this is not going to be true anymore. Okay, this is the easy version. So if this is still trouble, you need to come in on Monday.